Hi everyone. Today I would like to talk about design of a YouTube. Many years ago I've got this interview question and back then I failed it. So today I would like to outline how I would answer it as of today. First of all, when you get such an interview questions about system design, whether it's YouTube, Spotify or anything else, um, you need to ask questions to your interviewer. You need to treat interviewer like interviewer is a client, and because you can make assumptions, of course, when you hear about YouTube. But who knows, maybe interviewer wants some other system, maybe wants a rating system of videos and not upload of videos and streaming of videos. However, today I will create design for, especially for the most common features of YouTube, which is video upload and video streaming. In general, for this use case, we can consider two main roles, two main type of users. One type are users who own YouTube channel and upload videos, and another type of users that would stream those videos, would watch those videos. And the users who watch, so the amount of such users is way larger than the amount of users who upload. To start with the upload, we need to think where to store those videos. So the best place to store them would be object storage, such as S3, for example. Why object storage and not any other kind? Why not block store or shared file system? I think the most important part here is cost perspective, because in the object store, the cost is way lower than for a large amount of data than in any other storages. Of course, object store is also way more scalable and it's highly durable. So there are many durable options for storages, but usually object store have even higher durability than other storages. So even lower chance that your data would disappear. And often often object store, they have different money saving options, different tiers for storing data that is infrequently accessed. So, and it also can be very relevant for videos. Okay, so to upload videos to our object store, we need video upload service. And this service would be hit by client application, web application, for example, when a user uploads video. But along with video itself, user would send some metadata for this video. And this metadata should be stored somewhere else because object store is not best place for metadata. Obviously, there will be a need to search this metadata, to index this metadata, to work with it actively. And then we need database. Additionally, this database, we need to store metadata there, but we will need to read it as well. And we don't want to have shared database ever, because in the world of services, it's a bad pattern to create shared databases. That's why I will introduce also metadata service, which will have database, and our image upload service will call our metadata service through an API and put metadata, send metadata to the service, and the service would store it in the database. But what database is better? And if we are talking about interview, we usually need to choose between types of DB, not between some particular engines. And we often choose between relational or non-relational databases. To be honest, in real system, there are many considerations, and both databases would be acceptable. But from design perspective, for our YouTube metadata storage, we would prefer having NoSQL database rather than SQL database. Why to go with non-relational DBs? First of all, there is no need for hard schema there, and we unlikely would have many relations. And in NoSQL databases, we don't have full consistency, but we don't need full consistency for storing metadata of videos. Eventual consistency would be enough, but what we gain with NoSQL is better scalability. It will better uh, allow us to have multiple reads comparing to writes. So NoSQL would be a better fit here in this case. So now we have services to upload videos and to store metadata. But what's missing is processing of videos, because it would never happen that YouTube would directly stream the video that was uploaded. Instead, there need to be done some updates like encoding, maybe resizing of video. Also, often there is a need to generate video in different levels of quality for different speed of connections. So to do all this, we need some pre-processing logic, video processing logic. And this video processing logic cannot be done in video upload service because it's very different type of workload. And it's impossible to do it synchronously because it might require a lot of time. That's why we need asynchronous jobs for it. And to properly communicate from video upload service after video got uploaded, it should push a message or multiple messages to a message queue, and then those messages would be picked up by some servers that provides workers for different kinds of image processing tasks. So with it, we introduce also message queue, and we introduce a service of workers. So this service of workers will pick the image from S3, will do some processing, will upload the result images back to S3, maybe we'll also update metadata. So now we have everything we need to upload and store videos. And we can come to a part of playing videos and of streaming. But first of all, the role of a viewer, in this role, a viewer needs to find those videos. So we need to introduce some logic for search. I won't go too much into it, but for textual search, probably we need one another system such as Elasticsearch, which would provide efficient way of storing and searching and working with textual data. But also there might be different types of filtering or maybe showing information about video such as naming, description, text, etc. This can be done by calling our metadata service, which will get this information out of the DB. And finally we come to so our viewer has found the video, and he or she has pressed play button, and at this moment we need to stream those video. Our video is stored on S3, and the process of downloading video it can take quite some time. And this video can be played from multiple regions. But what often happens is that certain videos are played in certain regions multiple times. So, and we need to release this pressure of downloading each and every video multiple times from our object store. To do it, there is a system called Content Delivery Network, or CDN. CDN provides servers, so-called servers on the edge. So this servers are located near large cities in different regional areas, and they are caching data on their site. So if video is often played in certain large city and called by multiple users, there is no need to go each time to object store to download it. Instead, our service, our streaming service, would be behind CDN, which will cache somewhere nearby the end user. So this trick, it allows to decrease the amount of traffic from one side, decrease the amount of calls to our backends and to our storage, and on the other side, decrease the latency for the final user. And maybe one last thing to add here is that our metadata service, it reads from DB, but again, we have the same situation. We want to have caching. First of all, this metadata service also can be behind CDN, so we can also cache the responses of it. But additionally, metadata service can have own cache, and own cache, it would be some caching system such as Redis or any other similar system. And the requests that come most often, it will first search in cache, and only if there is nothing in cache, it will go to database, read it from there, and also store it in cache, and simultaneously return a response to a user. So, okay, that's it about design of YouTube, and thanks for watching. Bye bye.